property of light as it travels through our atmosphere. And this property is what's called refraction. So I'm sure that you've heard of the speed of light in either previous classes or in high school or just anywhere else in life. I'm pretty sure you've heard the idea of the speed of light. Well, what if I told you that the speed of light actually isn't constant? No, instead, the speed of light actually changes as light travels through different objects. And we call these objects medium. As light travels through different media, such as the atmosphere, or water, or another type of fluid, or through empty space, what we call a vacuum, its speed actually changes as it transitions from one to another, as it transitions from one medium to another. This creates an interesting property called refraction. So the idea here is that if light enters and it transitions from one medium to another by going straight through, meaning that the light, the beam of light is traveling perpendicular, so at a 90-degree angle to the surface, that the boundary surface between one medium and another medium, it just travels straight through. Its angle doesn't change, its direction doesn't change, nothing changes. However, if this light comes in at an angle, well, when it hits that boundary, the boundary where one media ends and another one begins, it actually begins to bend. And so light actually bends as it travels from one medium to another medium. The example on this image right here is you have air, and then you have this glass of water. And when light hits the surface of that water, its speed immediately changes because the water is denser than the surrounding air. This causes that beam to bend. So this is what's called refraction. Now, refraction actually leads to some really interesting atmospheric optics. We're going to talk about a few in the next video, but right now there is one I do want to talk about: mirages. Mirages. One interesting thing about this light, though, is in the case that the gas, or in the case that that medium also does a good job of scattering, it can change the direction of light and scatter the light in different directions. This actually happens with the formation of rainbows. Again, we'll talk about those in another video. But now let's talk about the idea of mirages. So, the first mirage that you'll often see is when you're actually looking up into space. And when you're looking up into space, you see all the different stars. Well, believe it or not, except for the stars that are directly above you right now, the light from all of those other stars had to enter the atmosphere at an angle. And because they had to enter the atmosphere at an angle, rather than coming straight in, like this star right here, the light from this star, they bend. And the bending of that light gives you the impression that they've come in from a different direction. Hence, rather than the star appearing where it's actually at, it will appear to you like it's at a different location. So that's one type of mirage. But there are two other types of mirages, and these mirages are much more common here at the surface of the Earth. And these mirages have to deal with things like seeing water on the ground, even when there isn't any water. If you've ever thought of like a really hot day, sometimes it'll actually look like there's a big pond of water on the ground. That's actually what's called an inferior mirage. There's another type of mirage called a superior mirage, and a superior mirage will actually make mountaintops look a lot taller than they otherwise would be. So let's talk about this inferior mirage first. So, the way that an inferior mirage works is during the daytime, especially when it's really, really hot, the temperature of the surface of the Earth becomes really, really hot. Don't believe me? Try to walk around on the ground barefoot at 2 o'clock in the afternoon on a midsummer day. Your feet are going to hurt because it's really, really hot down there. Well, this also means that the air right near the ground is really, really hot. But because air is a poor conductor, the air a few feet above the ground isn't nearly as hot. And so you get a setup where the air near the ground is really hot, whereas the air slightly above the ground is not as hot. Now, one of the interesting things about this is the air near the ground, because it's so hot, it's also substantially less dense. And because of that, it behaves like a different medium than the cooler air above it. And so the density of the air here near the ground is much lower than the density of the air a few feet above the ground. Well, here's what happens. When you have an object such as a tree, or such as a car, or even another person far away from you, the light from that person is heading towards the ground at a relatively small angle. Now, as that light, on its journey to the ground, enters that much warmer air, that new medium, it then bends. And in fact, if the ground is very, very hot, therefore the density between the surface and the air a few feet above the surface is very great, that angle, that angle of refraction, that bending, can be so great that that light that was heading towards the ground will bend back up. And from your eyes, it'll look like that light is actually coming straight off the ground. It almost looks like the light hit the ground and reflected off the ground. And so that gives you the impression that something reflective is right near the ground. So a puddle of water, for example. Puddles of water, at least that very, very surface, can oftentimes look like mirrors. They can be very reflective. But nope, believe it or not, that light's not touching the ground. It's just because as it was heading towards the ground, it bent due to refraction, due to transitioning from that much denser air to that much less dense air that caused the light to bend, and it goes right into your eyes. Now this is the inferior mirage. A second type of mirage is called a superior mirage. In the case of a superior mirage, you have cold air near the ground and warmer air higher up. If you don't recall from class, we call this an inversion. So an inversion occurs when you have warmer air higher up, and so temperature actually rises once you get to a certain height. Normally temperature drops as you travel up in the troposphere, but in this case you have a warm layer higher up, and so temperature increases. Well, again, you now have dense air here near the ground, less dense air higher up here. And again, as light reflecting off of an object such as the Rocky Mountains, as it travels towards the ground, it enters that new density. It essentially enters another medium. That causes the light to bend. That bending then, when it hits your eyes, it gives you the idea, the impression that it's coming in from a much higher angle than it was coming in. And so it'll look something like this. So just to recap this idea, you have light that's coming off of a mountain or some other higher up object, maybe an airplane or other distant things that are really high up, and that light, as it's approaching the ground, enters the new medium. And because it enters it at an angle, rather than coming straight in, rather than being perpendicular to that boundary, it enters that medium at a new angle, it bends. And therefore, it's coming towards your eyes from a different angle than it was actually coming off the mountain. Therefore, it appears to you that's a lot higher than it otherwise was.